So in this video, we want to describe the transformation that maps y equals sine of x onto each of these. Now, before we go any further, sine of x or cosine of x or tan of x, they look the same kind of structure as y equals f of x. So if you compare y equals f of x with y equals sine of x, then they look to be the same. Now, I have written these down in that way for a reason. Now, you'll notice that y equals f of x, we have a bracket around the x. Y equals sine of x, we quite often don't bother drawing the bracket. Okay, if it's just y equals sine x, or if it's y equals sine of 2x, or something like that, right? We quite often don't bother drawing the bracket because we understand what it represents. Now, you could say that's in part a bit of laziness, right? But essentially, there is a bracket around the x. And so when you look at these side by side, you're going, oh, well, okay, well, then the f is just this sin bit, okay? So this is really just saying this is the name of the function, and I understand what it does. So when you see this, for example, let's look at that number 1. We have sine of x plus 5. I get asked, is the plus 5 inside the bracket or outside the bracket? Okay, so if you write this, then what this means is the plus 5 would be outside the bracket. Okay, and I would always take it to mean that. If I wanted the plus 5 to be inside the bracket, then I would put it inside a bracket to make it clear, like number 2. I would have a bracket around the x plus 5. Okay, so if this helps, okay, and you don't see a bracket around the x, pop a bracket around the x, pop a bracket around the x, and so it will be clear. Okay? But, you know, you do need to get used to seeing that notation and just understanding what it means. So let's work our way through then. So this should be relatively easy now that we've practiced with other functions and we've practiced with f of x as well. So number 1, y equals sine x plus 5. Well, we understand that this is a translation like all of the other ones here because we're either adding or subtracting something inside the bracket or outside the bracket or both. So this is a translation by, and we describe it with a vector. The x inside, we're not adding or subtracting anything inside the bracket, so there is no movement horizontally. The plus 5 affects the vertical direction, and that is as you expect, so we are moving 5 units upwards. Number 2, this is a translation by. Now, we've got plus 90 inside the bracket, so that affects the horizontal direction, and it is the opposite to what you expect, and so that translates it 90 to the left. We have nothing outside the bracket, and so we are not moving vertically. Number 3. We have minus 90 on the inside, that affects the horizontal direction, and it's the opposite to what you expect, so that is positive 90. And we have negative 2 on the outside, that affects the vertical direction, and that is as you expect, so that's negative 2. Number 4, this is a translation by. Inside we have plus 180, so that affects the horizontal, and so it's the opposite to what you expect, so negative 180. And on the outside you've got plus 1, that's the vertical direction, and that affects the y direction, and so that is as you expect, and so that's positive 1. And the last one, this is a translation. We've got negative 45 inside the bracket. That affects the horizontal direction, and so that's the opposite to what you expect. So that's positive 45. And you have negative 3 on the outside, which affects the vertical direction, and that's as you expect. So that's negative 3. So the final one there is a translation by the vector 45 minus 3.